This is our lab 2. We are doing the construction of the AC high voltage generation and measurement. So now we have all the apparatus here, and we will now figure out how to construct this in a manner that doctor has shown us in the video before. Right now we are trying to figure out and read the serial number first. We have received the serial number data sheet up there, and we are figuring it out how things goes where. Now Edzham will demonstrate how to connect to the braided.
Yeah. Today we are going to do some connection for our HV lab testing, and the first connection we are going to connect between FC and our HV transformer. We are going to extract one phase from our FC and connect it to PU and PX.
And the ground must be stable to the braided cable. Alright.
So
Next thing is the braided cable must be attached to the transformer. This is for the secondary, this is for the second double grounding purpose of this.
okay.
Next, we will check the connection because the nameplate says to get it in, it must be connected like this. Alright. Next, that's the pedestal that must be placed under the grounding switch. Placed like that. And the capacitor must be on top of it. It's quite heavy. There you have 100 picofarad of capacitor, and it must be like that. And next we have the electrode that must be placed on top of the capacitor. I'll be done. And next we have the connector. Oh, careful. And the connecting rod that connects between the transformer and the grounding switch capacitor. Okay, now the important part that this grounding switch must be latched onto the electrode all the time. Next part is Ashraf will demonstrate how this one will have to be connected with the banana, female and male, and we must check the serial number from the data sheet so that it does not get, we don't get confused with it. So this is the same serial number of the secondary capacitor. Alright, let's check. And must be placed like that.
Sebelah sana ya. Betul ni? Boleh? Sana, sebelah sana. Ni sini kan? Sini? Sebelah sana, sebelah sana.
The connection that we must do is this one must be outwards. The indicator is this ear that goes out, that is the ground. So this one is the ground, both of this and this other one is not the ground. So it is connected by coaxial cable from the capacitor to the secondary capacitor.
This is a 100 picofarad capacitor arranged in parallel configuration. The total capacitance is 2 microfarad. There is 100 picofarad, 100 nanofarad capacitor arranged in this configuration. Oh, God. Tak lama. Oh. Sini nama dah ada itu. Dah.
Okay, that is secure. Now it has to be placed on top of that so that the braided ground cable can be attached to it.
Ni cucuk mana? Sini dia.
The ground cable that must be connected to the ground. The coaxial cable used is this RG58, which is only 50 ohm coaxial cable. Alright, there you go. There are two coaxial cables that must come out from the secondary device. Okay. This one will be connected to the frequency converter on VM1, and that is for AC measurement. Okay, secured. The second one, also from the secondary device, this coaxial cable will be connected to the picoscope, which is the ground must be, of the braided cable shall be now connected with the capacitor. As mentioned before, this is for double grounding purposes. Now, after having that ground secured there, the braided cable now must go to the secondary cable, to the secondary unit for grounding. That, and it goes there and secured at the secondary unit. The grounding circuit is now complete. Now that it's from the bus bar to the FC, goes into there, and then it goes to the transformer through there, and we have this first grounding and then the second one, and then it goes to the pedestal of the capacitor and the switching of the grounding switch and the secondary unit over there. Not sure if you can see it, but it's there. Yep, it's all secured now. This is the completed circuit of the construction of AC high voltage generation and measurement. Now we are going to shut the cage, close, so that it can be in operation. Perfect. This is the grounding purposes. So all of it must be grounded. The cage must be locked and secured. Now, if you can actually see, the grounding is all connected together with the Faraday's cage. So you have it there and all throughout the cage, like here, here, there, all throughout the cage. Now, to dismantle it, we have to ensure our distance between the transformer apart, and we are wearing a proper glove to dismantle it. And now what we are going to do is to discharge it and pull out the discharge rod so that it discharges properly. That's how we're going to do it. Perfect. We have also placed the discharge rod securely there. Now we're going into the control room. That is for testing purposes. And that makes sure that everybody goes in here and the door is fully shut so that we are safe in the control room. This is the picoscope that connects the secondary unit and the control system.
To set up our parameter, first we need to know the specification of our hardware. In this experiment, we are going to use secondary capacitor of 22341007605 with the divider ratio of 19,749 and 0.4. Okay. First, we are going to set up our parameter. We go to kit control, setup, and customer setup. Okay. There is a few parameter. This is manual step. Manual step will correspond to our sergeant, corporal, and private. So this is the least significant. The one arrow is least significant value. The double arrow is middle one, and the three arrow is the faster one. So we can set here how many steps we are going to change for every click. We can set up it 10, 1 and 0.1 for precision. For impulse sequence setting, it will remain in default mode. Component setup will remain in default mode, and we are going to set up our calibration. So we set up according to our data sheet, which is 19,001,9,749.4. Okay, and the other for calibration, first we are going to set up and input our numbers, and according to the video we watch, this one RM1, RMS1, we are going to set for 2. Peak square root is 1, and RMS2 shall be 1. Okay. Next we are going to save all our setting. And save it to our name. So we let it to entry 2, 3, group 5, and save. Okay, and we can load our setting. So it's here for our setup. We are done setting up our kit control. Okay, and in here okay, this is to change our input to control our primary input. Okay, and here we can see what are the power supply to our primary winding of our transformer, and this is the current. So for the output of our secondary, we can see it here and here. Sorry for the connection error. We cannot see actually where is the track. Okay. So this is the indicator alarm for alarm. Okay, whenever any interlock is breached, the alarm will turn red, so we cannot operate our HV. Once we set our primary, we can just press start, and in 7 seconds we have to press start again. This is a safety, double safety for our operation. Okay, thank you. Okay, next we are going to set up our picoscope. First, we load our picoscope software, which is according to our model is picoscope 3000 series. Load the software, key lab measurement. In here it states key lab measurement. Okay. So however we have some error here. Let's okay, for the acquisition setup, acquisition setting is how much we want to set our sampling. It can be 0 to 10,000. 0 to 100k of point of sample. Okay, so sampling interval.
Actually, what is sampling?
Sampling interval is the time difference between each sampling. Okay, so what these two parameter will correspond with our quality of waveform. Okay, the larger the sampling, the smoother our waveform will be. Okay, next is we are going to set trigger. Trigger should should be set to inactive. Impulse should be set to inactive since we are measuring AC HV. So channel, we are going to activate the channel active, and coupling change it to DC. Okay, divider ratio. Once again, we will refer to our specification. We going to input 19,641.1. Okay, sorry, that is a wrong specification. We are going to key in 19,749 at divider ratio. Offset is we let it remain to 0. Actually, this one corresponds with where we are going to measure. If we put it 1 volt, so our measurement axis, x-axis will start at 1 volt. Let's see. Okay, so next we are going to activate channel A and change it to AC. Okay, now we are done with our picoscope setup. Once we start our measurement, all the measurement will come out here, which is what, since there is some error in here, we cannot see the measurement. However, we have to click to AC because our measurement is in AC, and we will get all our parameters. Okay, before we start any of our measurement, we have to make sure our system is perfectly calibrated and the error is within our range. Okay, how to do it? One, we are going referring to this calibration sheet. Okay, we are going to set our output voltage at 10%, 25%, 50%, 75%, and 100%. And this is our reference value. Okay, how there we will set our calibration value. First, we change the value until it change to 10%, 25%, 50%, and 100%. this is the nominal frequency. Make sure is 850 hertz, and we can get later on we can get our result, which is here, and we should put the result in our table like this one, and we should measure the error. The error should be V reference minus V display over V reference times 100. There we will get the error percentage. So the purpose of this activity is to make sure our reference and our display or our measurement is not too big. Ideally, it should be if the reference is 10 kV, our display will also 10 kV.
Plus minus.
Okay, thank you.
After discharging the equipment, we are now going to dismantle the whole apparatus. And that has to be done with a proper glove. So that's the connector. Also, what Edzham is doing right now is opening up the Faraday's cage.
You're doing a very good work, Safiee. Keep it up.
Don't forget the connector. And we are now done with dismantling. Good job, guys.